So I'm here to talk about custom UI controls. I'll start off, I'll give you a little bit of background about me. My name is Luke Wallace. I head up the Android development at BottleRocket. BottleRocket is a local app development shop. We do iPhone, iPad, Android phone, and Android tablet apps. We do mostly apps for big brands. They come to us through recommendations from other clients that we've worked with, or we actually get a lot of recommendations on the iOS side directly from Apple. We've done enough to kind of catch their eye, and so one of our big draws that we always like to put into each app we do are these custom UI controls. I'll demo a few of them throughout the presentation just to give you an idea, but we definitely don't do just your standard list views and checkboxes and all that kind of normal stuff. And as we go on, you'll kind of see what that means. And I'm doing this presentation mostly because it's an area that we have a hard time finding developers that are good at it, have much experience at it, and it's just an area that iOS seems to be ahead of Android on as far as how well that kind of stuff is educated within the community. So this is just part of giving back and trying to raise that bar for everybody. So that's a little bit about me. This is what we'll be talking about tonight. I'm going to try to keep it limited to about 15 minutes of the time, maybe in the slides. The rest of the time it'll actually be looking at code, and I'll be trying to demonstrate how these things work. So don't be too scared of some slides that you're seeing. We're going to talk about attributes and styles. That's a really easy way to customize stuff. Then we're going to talk a little bit about compound components, actually taking existing components and just kind of combining them into simpler components that then you can reuse a lot easier. Then we'll talk a little bit about completely custom components, getting into things like the rendering pipeline. And then I'm really more open to Q&A throughout, so if you have questions, just raise your hand, and as long as they pertain to the topic at hand, because I don't want to get too far ahead of myself. And I'll be using code examples throughout, so don't worry, this won't be all slides. Where I got most of my resources, I could say developer.android.com, which I'm sure is a big resource that we all go to all the time to look up things. They actually have a whole section on custom components, but it's about 1 page long, and it does about the simplest possible examples you could imagine, and it doesn't really give examples of anything, and nothing. I don't know if any of the examples are as complex as what I'll show you tonight, and what I'm showing you is not that complex. But my big resource has always been Josh Elke, and you may not have a Josh Elke that you know, but I know one, and we basically hired him a couple months after I started at BottleRocket. He applied, and he had done, his background is more like R&D Samsung development. He worked at Samsung doing R&D for nothing that ever made it onto production devices, but lots of custom controls. And so he's our resident expert on how do you make something really magical. And so I'll be showing some stuff, and I may mention Josh a little bit later in the presentation. So when you hear that, this is who I'm talking about. So why do we do custom styling, and how do we do it? Like, what are kind of the basics of it? Well, the idea is that we change, when we talk about just styling something, we're talking about changing the look, but not necessarily the behavior in any way. Usually this can be done through XML, so it doesn't require a lot of Java coding or a lot of understanding of rendering pipelines or anything like that. You might use a styles XML or a themes XML to kind of help apply these styles across multiple views. And then another real common way is state drawables, which are actually just more XML. And I'm going to actually demonstrate some of that. So we're going to do a code demo. So what we're going to try to do is turn that slide. So what we're going to do is take a plain checkbox and turn it into a styled checkbox. So now we start getting into the code, and I hope all the fonts are big enough. We did a check beforehand. So let me show you the project that we got. It's called custom controls. And just for completion, this is the manifest. There's really nothing in here. It's just a single activity. But I just wanted to show that for completion. And all the code and the presentation will be made available at the end of the presentation. So if you're taking notes, that's great, but this will all be available. So here's our activity. If you've done any Android development, you probably know how an activity is basically laid out. So it's a linear layout that we're just going to have. It's going to be oriented vertically, so all the elements will be stacked on top of each other. And we're just going to draw one regular checkbox at the start, and then we're going to start on this second checkbox. And we're going to try to make it a styled checkbox. And so how a checkbox works is click. Did my emulator crash? That's always a good question. Yeah. This may have crashed. Let me start it up real quick. So how a checkbox works, I can still explain it, is you can give it an ID just so you can reference it. You set its width and height. Wrap content basically just says just be as big as you need to. And then if you give this text attribute, if you put this text attribute on a checkbox, that will draw a label for the checkbox. And that's how you get things like this, where you basically get a checkbox with the word whatever you put in next to it. Also, just for completion, I'll show you my strings. Those are all my strings. Plain checkbox, style checkbox, angry checkbox. You will see what an angry checkbox is later. But just for completion, I'm showing that. Let's see how that emulator's doing. He's warming up. So what we're going to do for checkbox 2 is just start off and set the text to be a styled, or set the text to styled checkbox, and it's going to look exactly the same as the plain checkbox, except the text will be different. But that's obviously not all that we want to do. So we want to start styling it. So the way you style it is you set a style on it. And so let's go look at the style definition. And you might write all this before you actually test anything. So we'll make up one style. We'll call it styled checkbox. And then we'll set the button. If you look at the definition for a checkbox, you can define what the graphic for a button, for the actual button, is. And so we're going to set it to be a, this is just saying it's in the drawable resources, and it's called style button. There you go. Amazing. So this has no style on it, so all we've changed is the text. You're like, well, that's not really what we wanted. So if we go back to our spec, we can see that there's, what we want is like a red box for unchecked, and then this green box will be what we use for checked. So what we do is we set the drawables as style button, and so this gets into our state drawables. Basically, what we're saying here is you can determine which drawable to show by the state of the view. Views can have different states, such as pressed. Checkboxes actually have this checked state. A lot of views actually have state checked, or they can be checked. There's also state selected. There's quite a few things in here. And so what this is saying is, this is a critical note here we'll talk about, is if the state is, if it's pressed, so if the state pressed is true and it's checked, we want to draw this drawable. And to show you what that drawable looks like, style button checked pressed, this is a shape drawable. Again, this is just more XML, saying it's a rectangle, it's got a 20 dp by 20 dp size, it's got a corner radius of 5 dp that rounds it a little bit, and the actual stroke that's used to draw it is 5 dp, and is this is actually a blue color. RGB, you can see the blue is the highest value, so it's kind of bluish, which you don't see there. But if we go back to the button, we can see that if it's just checked, then we'll draw style button checked. So if we look at that, it's got this nice green color, RGB, so this is all your G, so it's a green color. And it basically goes all the way down. Now, the important thing about state drawables is it always uses the first one it finds that matches. So your one that is unchecked, you always want to put last because there's nothing special about that one, and so you want it to skip all the other ones. The problem is this one doesn't turn them off. You could say if it's not pressed and not checked and not selected, then do that one, and then you might be able to change the order, but this is kind of the standard convention. I don't want to spend too long on this because this is not the real interesting part of it. But basically, if we apply this style to the checkbox, let's save. Sorry. If we save it and then run that, installing. Okay, so now we've got the red one, and you could basically build this up slowly. First, you just make a drawable, and you just set it to be this red button. So we've actually got 4 states here. So there's red, this red line. When you press on it, it does this little kind of shadowy effect on it. Then it turns checked, so now it's green. And when you press it and it's checked, it turns blue. And so that just creates a little bit of animation. I realize this is very, very, very ugly, but it's all done in XML, and the more time you put into it, the better you can make things look. And one tip I even saw is you can even go into the Android source code from later versions, let's say Android 4.0, and you could pull out the drawables used in those checkboxes, and you could drop them into your project and use them, and then it would work in any version of Android because you're actually referring to your own resources. So that's styling. Any quick questions on styling? That makes sense to everybody? It's pretty common. It's what a lot of people do. Any questions? Okay. We'll move on. So now we go back to the presentation. So now we can talk about compound components. So these are ones that actually combine other components. These start getting to the point where you really have to use some Java code for this. It's not real complicated at this point, and it can give you a lot of functionality. Generally, you just create a new class, and you inflate maybe your layout that you want to use. This is the easiest way to do it. During the fully custom one, we'll show another method. And then, if you create simple interfaces for your object, you can you can create something that's a lot simpler to reuse throughout your projects. Let's say you want to use the same checkbox on lots of different screens. You can create this compound component that does all your logic, and then you can just reuse it in lots of places. So usually this starts by extending a relevant view. If you know Android pretty well and you've gotten familiar with all the different views like frame layout, relative layout, linear layout, you might think of one that does a lot of what you want to do and just extend that. So instead of building everything from the ground up, you can actually say, well, it's kind of just a relative layout with some other things in it. And obviously, the more you learn, the more you'll be able to kind of feel out what it is that you should extend. So let's try making an angry checkbox. And so this is our spec. This is what we're told it needs to be. We want it to be a checkbox that we can give it text, and when it's not checked, it will show this little text saying, I'm angry. And then if you check it, now that text changes to I'm happy. And you're like, well, that's not really that complicated. I could just put all that in the activity, and I could just put all the logic in the activity, and then what's the big deal? Why not just do that? It's like, well, what if you wanted to put an angry checkbox on like 6 different screens? And then what if they ask you to change the logic of how an angry checkbox works? And you're like, okay, you got to change that color. Oh, I made a style. Well, we want to be below it. Oh, no, now I got to go to every single place and change all the layouts. So building reusable components has some obvious advantages. So let's get into that a little bit. So we'll kind of start off the way we started off before, and we'll just write a custom, we'll just throw our checkbox in there. But instead of referencing just the Android namespace checkbox, we'll actually reference a view that's in our own namespace. So this font over here is pretty small, but it's basically just in the namespace, com BottleRocket apps custom controls, there's this angry checkbox class. And as you can see, I'm not doing anything special here. There's nothing else in the styles, so I'm not even going to show that anymore. Get rid of some of those because we won't be going back to them. And so you can see this all just basically says, here's my class and here's my text. So now that we've added it to the layout, let's go over and see. I think I made an angry checkbox. I just have it extend relative layout, and I set up a couple of member variables that I'll use later. I know I'm going to have to put a checkbox in there, and then I'm going to use a text view to show the checkbox's feelings that we talked about here. So I'm going to say use a regular checkbox and this little text view that I can style a little bit. So we've got some constructors here, just all your standard constructors, and then we're going to inflate it. So basically, all these constructors call this same init, and then in the init, what we're actually doing is inflating a new view or a new layout, angry checkbox, and then we're using this. This is critical here. This is the parent node or the parent view to inflate this view into. So it's a relative layout that we're going to inflate this layout into. So let's go look at that layout just so you can see. So it's pretty simple. It's a linear layout. Since there's no modifier, it's horizontal, and it's got two things in it. A checkbox that we have an ID of angry checkbox, and a text view which we're going to call angry text view. This one has a little bit of a margin, so it's not bumped up against there, and we set a few attributes in this text view. And that's it. Basically, what this will do is when the view gets inflated, or when the angry checkbox view gets inflated, it will say also inflate this layout into myself, and then we're going to get some references to some of those checkboxes in there. And then I'm just going to, you can see the real code is in there. So here's what we get. So we get a checkbox and a text view. And one thing you might notice is there's no text there, even though we set it in the layout. We set the text. Well, the problem is we told angry checkbox that we wanted that text to be that. The checkbox that we inflated doesn't know that. So to do that part of it, we can pull off that attributes. We can look at that attributes parameter that comes in. This is passing in all the parameters from the XML layout, and we basically pull from that namespace, from the Android namespace, we pull the text value, and then what we're going to do is set that on that checkbox that we inflated inside ourselves, inside this angry checkbox. And so let's just do just that. And you can see here now it inflates and it passes along that attribute to that checkbox that's inside. So let's do some other things. Like, well, we need to do something when this checkbox is checked. So let's go ahead and set up a click listener. This is just real standard. Basically, we're just going to jump down and say call on checkbox click whenever you get checked. And then we have here the code that we'll now enable. Basically, we'll say let's check out that little reference that we've got, and we'll see if it's checked. If it is checked, then set the text to I'm happy, and I'm green, and I've got black text. And if it's not checked, then we'll set it to angry, red, and white. So let's just do that. well, that doesn't look right. But if we check it, we can see that it's happening. We can see that when it checks, the event fires, and it checks the state, and then updates that little view. So there's this little call in here that I did not do. It was on purpose. Everybody see that, I guess? It's pretty easy to see when I have all the answers just commented out. So we call it once just to make sure that it's set, because this doesn't actually change the state of anything. I mean, it changes the state of the feelings, but it doesn't actually change the state of the checkbox, so that's fine to initialize. So now if we rerun this, luckily this is a very small project, so it doesn't take long to do the builds. We can see now that on that init that actually sets up everything, it also kind of initializes the state. And so now it initializes it with the I'm angry, and then it checks. And then here's something that I implemented but isn't really being used anywhere in this particular program, but I basically created an isChecked method that pulls the embedded checkbox's checked state. So that way, if you're using something like the angry checkbox and you're actually referencing it in code, you can still say angry checkbox dot is checked and use that instead of having to try to, well, let me drill down and do a find by ID and try to find that actual checkbox that's inside. You can just abstract that out and use all those object-oriented principles that we all know are so important. So does this make sense to everybody? Not too scary?
You had to set the attribute, you had to set the text for the checkbox? Any attributes there?
So I set the text here on this angry checkbox. Because it derives from relative layout, I think you get this text. You can put this text in there. And then this is what actually pulls the attribute here. Because this attribute is what comes in when you init, and you can see that when this gets initialized. I forget which one of these is when the system inflates via XML. I forget if it's the one with the def style or not, but either way it passes the attributes onto that init, and then it just pulls it out of there.
I think one of the things the UV's got a relative layout, setting text on it, you're setting down to the checkbox, which wasn't the relative layout, right? Like this text on XML was actually on the relative layout.
Yeah.
They wanted it on the checkbox, so that's why you had to do that.
I'm basically hijacking the relative layouts text attribute and passing it on to that interior checkbox. Somebody at work asked me today, because I was showing this to people, and they said, what about custom attributes? You want to do XML with, oh, I want to be able to say, you know, angriness level equals 7, and I want that to do something different. You know, change the color of the red or something. That's all very possible. But that one is one of those questions that if you Google it about custom attributes on a custom view, there's lots of tutorials that talk about that. So I didn't want to get into that too much here. So this is just more of an example of you can pull attributes, and if you don't pull attributes, they don't just magically populate to all the children. So it's more of just an example of there's a little bit more work involved, but not. It doesn't necessarily have to be a lot. And again, I mean, these are pretty simple examples of, you know, of what you might build. But then the real advantage comes in, as many of these angry checkboxes as you want to put in, all you have to do is put in this code, and everything else just works. You don't have to constantly be including all this extra XML with relative layouts and checkboxes and text views all over the place. You can just basically throw this little guy in there, and it's a lot easier to read and you know, encapsulate and all that good stuff. So.
I'm not sure I really get. You have an embedded checkbox inside that relative layout. And it
Yes.
has text. That's the. It's got text and a text view. I'm missing why you didn't put text in the checkbox.
Well, I didn't put text in.
I thought you did put text in the checkbox.
So there's this right here where I set the text of the checkbox. So it's the same thing as here. If you look at these first two checkboxes, I set the text on them, and all that does is put a little label next to it.
Okay, but didn't you do it in the XML? I thought there was text in the checkbox on the XML.
Here?
Oh, I see.
But then that's on the angry checkboxes view. So here I have to populate it down to the children, because it's actually being applied to the angry checkbox itself, and so I have to set the text on the checkbox. I just have to pass it along so that it still works similarly. I could have done it a whole different way. I could have had custom attributes and done all that, but this was just kind of a quick way to pass that along. So now again, that's not real complicated. That's almost as much as you get on the developer website, but it's actually pretty useful, and this is actually a lot of what we do is this kind of stuff, and it can be very nice. But the real challenge comes when you want to do completely custom controls. So these generally require much more Java code, as you'll see. Again, you create a new class. You might not use XML at all. What you might do is some kind of hybrid. So what we did there is we kind of inflated everything that we needed through a layout, because that made it easier to define, and we're all used to creating layouts and activities, and so that can be very beneficial to do that. It's actually not uncommon at all, but you might want to do something where basically whatever they provide is not going to work, and we'll get into reasons why later. And so if you're not using XML, there's this function called addView, which basically adds a view as a child of the view that you're in. So I could have also called addView in that init of the angry checkbox, and that would add another view as a child. But I'll show that here in a little bit. Another common thing that you end up using is your display metrics density. Basically how dense is the screen, because you need to be sure everything's scaling properly. And one of the big reasons that you might use a custom control is because you want to draw your own graphics in your own places. But before we start talking about drawing graphics, we have to talk about the entire view and talk about the rendering pipeline. I put rendering in quotes because there's probably about 1,000 steps, but there's kind of these three main points where you can really insert your own logic, and it really handles a lot of the other work for you. It's three concepts: measure, layout, and draw. Measure, layout, draw. Those are very important to remember that order and remember each one, because they can all have a big impact. Draw, obviously, but the others people don't really think about too much. So measure is what is called when the parent needs to know how big its children will be. And it's not exactly right, because measure, so on measure you get these two things: a width measure spec and a height measure spec. And it's not just a pixel value; it's actually kind of encoded. It's a measure spec. There's a class for it that has some utility functions that help you pull out what you need. But it combines those attributes that you're probably used to seeing of like fill parent, wrap content, and the actual value of how many dp, how many pixels, all that. It kind of wraps it up into a single value. And so using this view measure spec class, you can actually get all those individual numbers out. And really what it's doing is it's telling the parent how big your control wants to be. It basically says, how big do you want to be? I'll come back and tell you how big you are later, but I want to know, if given unlimited space, how big would you like to be? And how the children tell the parent that is they set the measured dimension with an actual pixel value, width and height. I think that confused me for a while, that you get, like, you enter the onMeasure function with this complicated hashed value of parameters and values, and then you return just a pixel number. And yeah, there's math involved. So if you don't like math, this is where it starts getting a little hairy. Then we talk about layouts. It's measure, layout, draw. So layout says, this is where you're going to go. the first parameter in on layout, which is the method that you'd override, is changed, whether this is a new value or not, and then you get left, right, top, and bottom. Basically, you're told, here's your space. Here's where you draw yourself. This is all you get. Don't. If you draw yourself bigger than that, well, you're not going to be seen. So it's telling you, here's how much space you got. And the magic happens between those two things, where the system will actually figure out based on linear layout weights and how things are aligned, basically figuring all that out for you. So that's the advantage. That's why this is just kind of a simple pipeline. Then draw gets into the interesting part. That's where you're actually given a canvas and you can do whatever you want with it. And it starts in that same kind of layout perspective of like you start at 0, 0, and that's how much space you have. And so you have to keep track of some of those numbers. But it's not too complicated. There's on draw and then there's dispatch draw. Dispatch draw is when the children are getting drawn. So to draw things after all the children have drawn, and things are, you have to think about things in kind of a Z order, right? The first thing that's drawn, it goes on the bottom. Then when you draw something else, well, that's going to be on top. And then you can draw something else, and you might put some alpha transparency so you can kind of see through it. But everything kind of gets drawn on top. So if you need something that goes on top of everything, you really need to call yourself at the very end of dispatch draw. And we'll get into some of these examples. So I realize this is a little more complicated. So I was trying to think of like a really simple example of what we might do at Bottle Rocket for something like this. And so what we might do is something like a slider switch. So instead of having a checkbox of on, off, you might actually have a little slider. Maybe that fits with the brand, maybe that fits with the motif of the app, but we want to have this little slider that you kind of slide left and right. And I'm not going to implement everything about how it would integrate with all the other screens and checking the is checked value and a bunch of stuff like that, but we'll get over how most of it works. So let's go over and put some stuff in here. So I think we're done with the angry checkbox, which is fine with me. And so we're going to bring in this slider switch. We're going to call him ID 4, or we're going to call him checkbox 4. And this one we're actually going to set widths and heights. This is where it starts getting a lot easier for quick demo purposes to just set exact values and move on. But in actuality, you might want it to scale. Maybe you don't. Maybe you always want it to be 150 dp, which itself is a scaling amount. So it's all kind of up to you. So we're going to start with, we'll just uncomment that, and let me make sure this will actually compile. And so we're going to do something like slider switch. And we're going to, again, extend frame layout. It just gives us kind of a nice building block to build all of our layouts on. You could go down and extend view, but extending something like frame layout, you can get a few layout things when it's being aligned inside other elements and all that. So it's a real common one that we use. We're going to set up some things. So we're going to have a slide bar. That's actually going to be this little bar that this little slider kind of slides along. We'll have the actual slider itself, which we're just going to draw as a bitmap. There's a paint. I'll maybe mention that a little bit later. And we're going to keep track of the density just so that as we make calculations, if you're doing things like scaling, you don't want to have to go look up the density every time. Since it's just a float that will never change as long as the person's using the device, there's really no point in doing all the work to look it up every time you need it. So it's real common that we pull these things out. Eventually, we're going to want this bar to move, so we're going to save the slider position that we want to draw it at, and the max and min position, and this will be more relevant later. So it's going to start off looking a lot like our angry checkbox. We've just got kind of our constructors that we've got, then they're all going to call down to this init. And init's all commented out, and so I think, so let's start pulling some of this stuff out. So first we need to calculate our density. And, well, let me see if this, I don't know if I ever tried running it with just this, with all this commented out. As you can see, we're never going to inflate anything in here. We're actually going to do all the views through just Java. So you can see nothing draws here. Kind of makes sense. We're not actually drawing anything yet, so that's what you get. You get nothing. So let's start calculating some things. First, let's look up our density, and let's try drawing that bar. So we're going to make a new image view, and we're going to actually set its resource to this slide bar. Now this is actually a graphic I believe I have over here. It's a little bar. Pretty basic. Now we need to put it in the layout. So we're going to set some layout parameters on it. You'll see things like match parent, faux parent, wrap content, and center vertically. So we basically are saying, let's say this slide bar is going to go the full width and then just as high as it needs to be, and let's center it in the middle. And then we'll add view, which is basically, again, adding it as a child view. So if you thought about an XML, you'd have a frame layout and then an image view inside of it. And let's go ahead and try this. So there you go. So now you've got this little slider bar drawing. Sure. Yes. Yes. If it's larger, actually this is probably being scaled down anyway because I think it's bigger than this physical space on here. Yeah, if you look at that compared to that, it's actually being scaled down for this right here. And you can see it actually scales it. It's probably hard to tell on the projector, but it's actually scaling it slightly vertically as well. It's scaling it down a little bit to keep that aspect ratio the same. That's where that wrap content comes in, is that it only draws it as tall as it needs to be to maintain the aspect ratio. So yes, that's the advantage of using things like image view and not actually drawing things yourself on the screen. So now we've got the bar. So we're like, okay, great. Now we got to do the hard part. So we need to create the slider. This little paint that we do basically just helps anti-alias some of the stuff. When you actually paint something in the on-draw, you'll see that there's a paint involved, and that's just a really basic one that makes sure things kind of look better. So first let's put our bitmap in there. So we're going to make our slider, which if you remember is a bitmap, and we're just going to decode it from our resources, and it's going to be this little slider drawable, which I had one of our creative people make up in a couple of minutes. I spent several minutes and made something very, very ugly, but they spent a few minutes, and so you get this nice little slider, and it's real pretty. So we basically decode that, and then here's where we want to scale it. We're actually going to handle the scaling ourselves. I cannot do this at first if you guys want to see. Basically, since I'm going to be actually drawing the bitmap just raw, that's important to do, but I'll leave that out for now so we can see how that ruins things later. So we got to start thinking about our layouts. Think about the rendering pipeline. Measuring is the first place that we'll actually get into changing anything. And since we're measuring, we can figure out what our max position is. Basically, we can say that the farthest, because you draw everything from 0, 0 in the upper left-hand corner, and x goes to the right and y goes down, the max position that you'd want to start drawing is the entire width of the slide bar minus the width of that little slider that's going to be going along that. If you let it draw farther to the right than that, well, then it's going to start drawing it in places you can't actually see it. So we'll set that up now since we can imagine what that's like. We are going to have to measure our slide bar and then set the measured dimensions. So basically what we're doing is we're just using whatever the image view gets, and we're saying whatever the image view wants to be, that's what we'll do. So here we're calling measure on it. This ends up calling on measure inside the image view. This is how you call it externally, and we pass in just the same parameters that we were given, and then whenever that, so that'll run, and then we can call get measured width and figure out basically what did it say, and we pass that value back up. So we're just kind of being the middleman here, and we're just passing along, and we're saying whatever that image view wants to do, that's what we'll do. And then we'll pull our position. So then we have to do, okay, measure, layout, draw. Okay, so layout. Actually, we don't have to do anything for the layout. So this is in here for just to show it. You could take it out because it's not doing anything except calling the super, but we're saying no, that does all the layout we need. We don't, all we have is this one image view, and it's added as a child. Since it's the only thing in there, we don't really have to do much with it. So now we need to draw our little bitmap. So measure, layout, draw. So what we're going to do is try drawing our slider in there. So we're using dispatch draw. Again, this is all the children. So what's the child of the frame layout? Well, it's that image view. It's that slider bar. We want to draw on top of that, so we just draw at the end of dispatch draw. Draw all your children, image view, done. Then draw, let's see, let's draw something. So let's draw a bitmap. We'll draw the slider. We'll draw it at the slider position, which starts off as 0. We haven't done anything with that yet. How far down do you want to go? We're never going to, this is a real simple example, so you're never actually going to move vertically. The slider just goes back and forth, so it's a lot easier. Again, another reason why I kind of picked this. And then here's that paint you got to pick. And so instead of creating a new paint every single time through the draw loop, it just creates it once and reuses it. Again, that's kind of an efficiency thing that we get used to. So let's see what this looks like. You can mentally make your prediction about what you think will happen.
Why did you take that one super out of measure?
Here, because that'll call set measured dimension for it, and so it won't take into account the image view. So, bam, there we go. It's awesome. Except that's not at all what we wanted. We can tell that this image view, when I look at it, I can tell this image view is actually too big. If you looked at the slider, this is kind of a trick that I made to make it work. There's actually a bunch of padding built into the graphic here. And so that's why it's drawing it lower. You said, well, we didn't draw it down any. Well, we didn't, but these first 100 pixels are all blank. So it's kind of shifting it down and drawing it exactly like that. So that says, oh, well, we need to scale this. And since I know we didn't scale it, we'll go back and we'll scale it. So we decode it and then we scale it. And I decided 48 dp is kind of the size that I decided to make it. So we'll just make it 48 dp times whatever the density is on this. And that will get us the right version. So let's build this guy up. Let's see. Hooray! It draws, right? So we're done. Now we've got this great thing, and you can just. Oh wait, that's right. Yeah, that's all great for drawing something, but no one really cares if it just sits there. Now, what you could do is say, we know it's max position. We could set checked on it. We could maybe add an on-click handler, and when you check it, it moves the position to that max position, and it would just kind of jump over there. But that's a little too boring. That's not really the way we'd want to do it at Bottle Rocket. Not so much for my interest, but that's what the strategists and the people that don't actually have to write any of the code want. They're like, hey, just make it when you detach it and move it. And you're like, yeah, that's a lot harder to code than it is to show like that. I got one of these the other week where they're like, I want it to go ching. I want it to go boom and open up. It's like, and I'm like, okay, what interpolator is that? What's the true interpolator? Boom, and I'm like, okay. So that's how they describe what they want. So you're like, it's a lot harder to do the code for that than it is to do the hand motion. So, but you say, well, let's not do that. We want to do something where you actually touch it, because we want this to. I mean, these are touch screens. It's a slider. People are going to want to touch this thing and slide it over. That's going to be your inherent thing. If you tell them, yeah, you can click on it and it'll jump over to the end, you're like, it's kind of lame, but whatever. And being like, this stupid thing, and like, why'd they make it look like something I could drag when I can't? So, what do? So, do we just pass the touches through? One option is always kind of like what we did on the angry checkbox, where they clicked on the checkbox and we didn't really care what they did with it. We kind of said, hey, let me know when you get clicked so that I can do something too, but you know, do your thing as well. Or do we do what we're going to do here and like really intercept those touches and actually change what we do for drawing? That's where it gets interesting. So how do you do touches? Well, there's another on touch event, and you get this motion event. Again, motion event. Now this one's actually an object that you can easily query and get values from. Typically what you're getting from it is get action. You're getting what kind of event is it? Is it the down event? Is it a move event? Is it an up event? And there's lots of parameters on there. There's get X, get Y. That tells you, where did this event happen on the touch screen. There's also there's a whole lot of different elements on different methods on there. Going out and exploring that gives you a whole lot of ideas, because it's like, wow, I didn't realize it was so easy to get those values for an event. There's even multi-touch stuff, because you can actually get X0, get X1, and so you can detect things like how far are their fingers apart on the screen, and then as they move, you could calculate all these different changes in those, and it's really interesting. So there's a lot of stuff you can do there. And then one thing we're going to do is we're going to use runnables to actually animate in the action up, and it'll become more obvious why we do that a little bit later. So as you move your finger along the screen, you're basically getting constant move events, and so it's firing those as quickly as it can. So you don't really get a queue of them. You won't get 4,000 as you move your finger. You'll just get one as quickly as you can. So as soon as you're done handling the first touch event, if the finger's still down, it'll probably send you another one of, okay, they've moved, and then as soon as they let their finger up, you'll get that action up one. So the move ones are kind of throttled by how quickly you can handle them, but everything else is pretty much as it happens. It's a good question.
Basically, you have your Z order.
Mm-hmm.
So you need to be cognizant of if it's actually on that view or not.
Well, that's where you have to. We'll get into some of this. So here's a little thing that I'm not going to really talk about more. This is again kind of trying to make it into a real checkbox. So what you could do is say, is it more than halfway to the right, or more than if it is, then that's checked. So let's get into some of this touch event stuff. So I'm going to show you some of our boilerplate stuff that you would see if you looked at a lot of Bottle Rocket code. There's actually the one thing you don't get on those motion events is, okay, they've moved and they're at this point now. That's great. Where did they start? It doesn't tell you that. You have to keep track of that yourself, because it doesn't know, do you actually want to track every single point that they go? Do you just care where they started? Do you care where they were a second after they started? What is your, they don't know your use case, so you end up having to save a lot of that stuff. So one thing you'll see here is M down X and M down slider position. So that was, so let's go ahead and start overwriting this thing. Woo. Fun times. This is where it starts getting interesting. So we're going to call onTouch, and I'm going to need to plug in for power, because there's a lot more of this. It's too short.
I will go get one.
Excellent. All right. So we'll see how long this lasts. I have a feeling it'll last okay. So we've got the onTouch event. As you can see, it returns a Boolean. this gets into the event handling. So if you return true, that means I got this one. If you return false, you're saying, this one's, I'm not doing anything with this one, so it's okay. Do it if you want it, you can have it. So there's usually a big switch statement in there, and those will return false. Typically at the end of just, if nothing happens that we want to keep track of, we will do it. So let me just pull in all this action down stuff. So if they just touched it, basically down is as soon as they touch it, you get one down event. You will not get, you don't get down events as they move. You just get a single one. So let's save off what we got. First, let's save where the slider was when they put their finger down. That'll be useful later. And then let's set where the X is. Again, this is really just a two-dimensional, or it's just kind of unidirectional, so we don't really care about the Y's in any of this. So let's get the position along the X-axis that they were at. And we'll save that. I can comment this back out for a little bit. And we'll return true, basically saying if, yes, if they touch down and it comes in on my view, I want further events. And that's an interesting thing about action down. If you don't return true from action down, even though I didn't really do anything on action down, I don't need to redraw, I don't need to do anything. If you don't return true on down, it won't send you any of the move events. So you have to return true there if you ever want to get the move events. Again, that's kind of a common problem that you'll see. So if they move, now we want to do something. So now they put their finger down. Well, a slider doesn't move when you just touch it. You have to actually move something. So what we need to do is we need to look at how much, we need to look at their current X position and subtract where they went down at. And so that'll tell us how far they've moved on that event. And we're going to add that slider amount. That's just the name that I gave this function. Add slider amount. And that one is also going to call set slider position. So what this does is set slider position just sets the slider position to, well, it does this little min-max fun so that it's between the min and the max. But this basically sets it to somewhere along that position. And the add slider amount is really relative to the down position, because you don't want to try to add how far they've moved since the last time you drew it. It's easier just to draw it from where they were when they went down, because it's an easy calculation. And I realize I'm talking fast about that, but it'll make more sense, or maybe when you see it. Again, all this code will be available, so you'll have your own time to dissect it and find all the bugs. Yeah. So now what we've got. So what do we got here? We've got a down event and we've got a move event. So the max position got updated in the onMeasure event. We set max position here, so it's safe. Good question though. If we take that out, you could see it. We can maybe show it sliding right off the edge. So now let's see. We touch, it should be grabbing it, and if we start pulling it, it'll actually move. So what we're doing there is this invalidate is the key. Basically that says I'm no longer drawing the right thing, you need to redraw me. So it goes back through the onDraw. It doesn't go back through onLayout and onMeasure. It just goes back through onDraw. And I believe that's what it tells you. Yeah, it just, onDraw will be called at some point in the future. Hey, there we go. So, pretty cool, right? So, that's cool. But now, again, that'll not be good enough for some people that I work for that don't have to code it. They'll say, no, I want to be better than that. Hmm?
You don't move it too well.
Yeah. Yeah. So they don't want to. They won't play with that. So you can just sit there and play with that all day, but you don't. So what we want to do is what they'll say is, well, when you lift up, we want it to animate so that it's always in one state or the other. We don't want it to just sit there in the middle. That's no good. So we're like, okay, well, animate to the end. Oh wait, I actually have to write that. So here's the is touching slider bug. Let me show you this first. So one thing you'll notice though, there's a bug in here. You can grab it anywhere because the down event gets caught, and then wherever you move, it calculates from that down event. So they're like, well, that's not very realistic. You actually have to grab the slider. So that's why you see this little is touching slider. So well, like down here? No, because this isn't in that same view. You can grab wherever else you want on the screen. It doesn't do anything. It's outside the view so the touch events don't get passed to it. Yeah, no problem. So we want to say, well, if it's not touching the slider, we don't really care about the move events. We don't want any of them because they didn't touch it. So then we do some quick math and figure out, does it actually touch it? So one way to do that is just to see, is the position, is this X position that we had, is it basically in there? So I'll let that come up. But, oh, that, so this is the M slider variable, which is the bitmap that then we scaled. So this is the actual bitmap. But we scaled that down. So, well, I replaced it in line. I did it in place. I didn't create two variables. So there's M slider, and then we replaced M slider with a scaled version of M slider. So, yes. So yes, that will be, you will be able to grab it up here because that's technically part of the graphic. Yes. So, yeah, not bug-free. You probably could. If it's something like this where you know what the graphic is, maybe you could just say, I know it's, the middle 50%, of the bitmap, so you can grab it in there. So you can see now if you try to grab over to the side, nothing happens because the down event says, nope, you're not in the slider, and so none of the move events go in there, and so now the calculations happen, so it doesn't get invalidated, so it doesn't redraw it. There's a lot going on. So now let's do the next cool thing, which is when you do up, let's do an animation. But that's not written for us. We got to go write that. So we're going to do some fancy stuff here, and I'm going to try to talk about this as much as I can without taking too long. Basically, we're going to create a little runnable. Let me show you what a runnable basically looks like. It implements the runnable class, which can do a lot of the work for you. That's the whole point. And we're going to keep track of which direction it goes. We're actually going to use a scroller, which will help calculate what the new positions for that X value should be. We're going to do some quick checks to make sure that we're not running two of these at once. This M slider runnable, if you notice, is actually up in the slider switch class itself. It's not. We actually keep track of this runnable. We use the same runnable throughout. We create this little utility method that call. Yeah, because it's like, oh, you must be trying to comment something out. So we'll have a start. We'll create a start and stop. These aren't overrides. These are just common ways we do it. Basically saying I want to start the animation, and it calls this post delay. This post delay is actually part of the runnable framework, where you can delay how long it is before it runs the first time. So that way, as soon as you let up, the animation doesn't start. It'll wait a second. It'll call start. It'll wait as long as you specify here, and then it'll start calling into the runnable, into this run. And stop removes all the callbacks on this, which is again a runnable framework piece. Basically gets rid of everything so that it just stops running, and we set that member variable to null just so that we don't have any going. And then you'll see some things in here. Let's see if I can do anything that compiles. But I'm pretty much just going to explain what's happening here. So as the runnable goes, we first check to see has it started. Let me just uncomment this out so it's this syntax highlighted. So much easier to read. And the errors go away. If we're starting the animation, we have to figure out where we're animating from and to. If you look at this, you get, okay, when they let up, that's where the position was. We know that's where it was. What we're going to do is the logic of, if it's to the right of center, we want it to go to the right. If it's to the left of center, we want it to go to the left. And that's just a very simple logic. So we know where our start position is. Let's figure out where our end position is. Well, if we should go to the beginning, the start is actually that min position. If it's going to the end, it's actually that max position. So that actually wasn't too difficult. This animate to start was a parameter that we set when we initialized it. We created it here, and it's basically a Boolean, and we just did the calculation right in line here. This could be extracted out to a Boolean of, go to start, but I don't. Well, hold on here. There we go. There, done. So this is where we set our Boolean. Comes down here. We set it to a member variable inside the runnable, and then we run it. So we figure out which position, and then we're going to use this scroller. Basically, the scroller gives you a value between a start and an end based on a duration. You could say, I want you to count from 200 to 400 over 3 seconds, and at any point you can just ask it, where am I, where are you? And it'll say, well, right now I'm here. And then if you just asked it constantly, you would see it just counting up, and it's counting up at the exact right times. So it's really nice for doing things like animation. And if you think about the name scroller, that's how they get all the scrolling animations and everything that happens in Android. That's what they're actually using, is something that is calculating all that for them. But you don't have to write that part, you just have to use it. So, and then in the initialization we say, okay, and we're done starting it. So because this run method is what gets called each time through the loop. So each time you see a post in a runnable, it'll post back and run this run method again. And so you got to make sure you don't initialize every time. You won't get anywhere. So we compute the scroll offset. This is the where are you method. And it returns a Boolean of whether it's completed or not. And then you can say get current X and Y. And here we're just using Y. If you look, the start scroll goes from 0x start Y to 0x end minus start Y. Basically it's scrolling that amount, the change. So it's basically scrolling the change from, like start at this value and then add this value over this amount of time. And then, so if we had more, we just need to redraw and we need to post. And you see we set the slider position. This goes back to using that method that we made before, where we set the absolute slider position. In this case, we don't need to add it to any sort of down because we know we started at 200 and we're going to 400. Well, if it tells us to go to 300, we don't need to add that to any sort of previous value. So it's not as complicated as it might seem, although I realize I'm probably talking really fast. So we say, well, if there was something left, we should redraw, and then we're going to post back to this. If we don't have any more to do, if we finish scrolling, we've finished our animation, then we can just stop. And then to remind you what the stop did, it basically cleans up everything. So it's real, this may sound funny, but I think this is real simple. This may sound, you may say, oh no, I do not have any idea what he just said. Again, all the code will be available at the end of this presentation, if that helps at all. That helped me a lot to be able to just look at this and play around with the different things. So now we see what happens. So we drag, and then now let's see if the magic happens. Oh, I let up. I'm going to let up right here. Oh, there it goes. So if we look at our duration, there's no delay, and there's 400 millisecond duration. So I could call it a magic trick and ask for someone give me a number from the audience. You know, anybody have any? So you could say, well, let's make it a 2-second animation, and it's only going to start after a second. Be kind of might be kind of awkward, but it'll help you see it a little slow. If it happens a little slower. Let me redo the magic trick a little slower, so that it's you can maybe see that it's not quite so amazing. And if you put breakpoints in at all these places, you'll be able to see all the events firing and everything. So here's what we do. I'm going to just drag it over to here, about to the middle. We'll see how that works. And then I'm going to let up 1001, 1001, 1002. So it's basically 3 seconds, right? So no magic tricks. Those are the actual values that are being used. This isn't some sort of other thing I'm doing. I just added about 100 lines of code. Does anyone have any questions about any of that? Stacey.
For some of this stuff that's a little more complicated, why not just run this as an extension of the GL service?
And do it all with like OpenGL or?
Yeah, because if you're going to do a bunch of animations and really fancy slider switches, then you'd rather just be able to write like 5 or 6 lines of code instead of having to have like 12 references for one slider switch.
OpenGL scares me, so I'm just going to say that this seems less scary. Yes, of course, OpenGL can do that. We've actually what? It can definitely render it on the OpenGL, yes, and it could be quicker. When you write a lot of stuff this way, sometimes it's easier just to keep writing things this way. So yes, feel free to learn. Feel free to do it with OpenGL. We've had guys at work, they've been doing stuff with OpenGL, and I do not see 5 lines of code. Like there always seems to be a lot more.
Almost like working with a jQuery UI in terms of your ease and ability to kind of add and change elements.
Yeah. Good idea. Let's like most development. There are lots of ways to do development. This is the way a lot of things happen in the Android framework itself. Yeah, feel free to do it with OpenGL. Feel free to do it with anything. This is just one way that uses a lot of the framework pieces. Yeah. It's for an hour and 15 minutes. There's a limit to what can be. You know, I'm already past my hour, so. But this can be used for other things, maybe just animate. I mean, this is obviously not a, you're not going to create games with this. This isn't how you'd want to try to create, some sort of platformer where, you're playing Super Mario Brothers on your phone. You probably wouldn't want to do it this way. This is definitely not your heavy graphics way of doing things. Any other quick questions? And I was going to demo a few other things that were built basically using all this same.
Well, my quick question was the functionality for a slider like this.
Mm-hmm.
I thought you were going to end up stopping it partway through, but you really made a checkbox that's really on or off.
Yeah. So you could do things. You could make this as complicated as you want. You could have 5 places that it stops, and it becomes kind of a selector of 1 to 5. Select the rating that you want to give something. Is it 1 to 5, and they can just grab it and kind of slide it along. So yeah, it's definitely extensible. This is very, very simple. I just felt like the animation piece is another big part that is not real well known. You don't see a lot of this. You see very, very little. So this is just kind of one way to get some more of that out there. And again, if you think about it, this is now this. This is how many lines of code you have to write everywhere that you want to put a slider throughout your app, anywhere in the layout. You can just kind of throw it around. So I was going to show a few examples. Let me see what else I had in here. Questions. Here are the download links for this presentation and this source code, if you're at all interested. I shortened them so they're pretty quick. goo.gl. These are all shared just via Google Docs. The first one is just a PDF, and the second one is just a zip with all the source code in it. Yeah, we'll be able to put. Yeah, we'll be able to post these meets to the link. To the meetup. These links to the meetup. These meets to the link up.
I think,
The meetup on LinkedIn.
and
The links
so
on-
we're gonna have a video of this also, hopefully, if it worked. And we could probably just add to the bottom of the PDF the link when it's available, right?
Yeah, yeah.
So it would be active in the PDF file. We should, if the video works, we will get the link to the video or to the screen cap.
I'm going to stop this